Good day, welcome back. I'm excited because I'm finally figuring out how the whole technology things work, and I'm really excited about what we're going to be talking about today. So today we're entering into fractions, which is sometimes intimidating for people, but it's because we always talk about greatest common factors, least common multiples, top times top, bottoms times bottom, and a whole bunch of other techniques. But I really want to focus on something, which is using prime numbers. Prime numbers is a number divisible by itself and 1. A number like 3 or 7 or 5. It can't be divided. This is also the basic building blocks for all numbers. So let's take any number. Let's start with 22. 22 is 2 times 11. Those are its prime factors. In other words, 2 is only divisible by itself in 1, and so is 11, which means that 22, the recipe, is putting a 2 and 11 together. And this works for any numbers. Now, you might say 4 times 5 starts as 9 times 5. 5 is prime, 9 isn't, so it's actually 3 times 3 times 5. So the recipe for a 45 is 2 3s and a 5. Now what does that mean? That means 45 could also be 3 times 15 or 9 times 5, because you can split it up any way you want to. We can even take big, huge numbers like 128. And the first step is going to be 2 times 64. But the 64 breaks down. So let's do 2 times 2 times 32. And then it keeps going into 2 times 2 times 4 times 8, which becomes 2 times 2 times 2 times 2 times 2 times 4. And the 4 still breaks down. So this is actually 1, 2, 3, 4, 5, 6, 7. That means to make 128, you got to have 7 2s. 2 times 2 is 4, 8, 16, 32, 64, 128. So whenever we're looking at a number, we want to remember that the prime number is the number divisible by 1 itself, and it's also the basic building blocks. To make 128, there's only one way to do it, which is 2 times 2 times 2 times 2. Several other different ways will get you there, but the basic recipe is to have 7 2s all together. Alright, so now let's see how this is going to work when it comes to fractions. So let's give a nice screen here, because I like the way it looks that way. So let's start with just reducing a fraction. If we had a fraction like 10 over 25. Instead of starting with what goes into both of them, I encourage you, building blocks once again, start with making prime factors. 2 times 5 and 5 times 5. Now what's going to happen is, if this can reduce, then you're just going to see that there's a factor on top and bottom that's the same, and that's going to equal 2 over 5. And this is going to work for any type of numbers combinations we do. So if we had 36, and on the bottom we had 100. Well, 36 is 9 times 4, which is 3 times 3 times 2 times 2. And 100 is a 10 times 10, which is a 2 times 5 and a 2 times 5. So you might have seen that 4 goes into both of them, but if you just start with this, then when we get later on, we can just say the 2's go away, the 2's go away. My answer for reducing is 9 over 25. So if you write out the prime factors, now some of them you're going to find have really funky. Let's throw something in there like a 39 and a 63. Well, the top is 3 times 13. 13 is sort of a weird prime number, not one people think about. And the bottom is 3 times 21, but that's 3 times 3 times 7. Now notice there's only one 3 here, but there's 2 3s down here. When I cancel out, it's 1 for 1. So 1 3 there, 1 3 there. And we get to 13 over 21. Alright, so this is going to be used when we start doing multiplying fractions, when we start adding fractions, least common multiples, greatest common factors, and things like that. But it all comes down to, if you understand this idea of prime factoring, then you never have to play the game of, I don't know what goes into both, or on something like this, dividing both by 2, then dividing both by 2 again. So there you go, the basics of prime factoring, so that you can simplify fractions. Next time we'll talk about multiplying fractions and working on greatest common factors, least common multiples. But for now, practice your prime factoring and you'll find life gets very easy when you start doing fractions. Thanks a lot. Hope it helps. Come see me at anyonecandomath.com. Ask me your questions and I'll see if I can make a video for you.